Good afternoon, everyone, and welcome to part 2 of ADA in Work Zones. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handouts section of the GoToWebinar panel, please note also that PDF copies of the course presentations are available for reference. With that, we will go ahead and turn things over to our instructor, Ron Eck, with the West Virginia LTAP Center. Hello.
Hi, Mike. Thank you. Welcome, everybody. Welcome back to day 2 of ADA in Work Zones. Without any further ado, let's get started. I believe towards the end of class last time, I think it was Eli had a question, if I understood it, related to having flush bike lanes and sidewalks. And here are a couple photos I took in Cambridge, Massachusetts a few years ago. I was in Boston for a conference and went on a pedestrian bicycle related tour. And these, you can see you have adjacent sidewalk and bike facility. Looks very nice, but not to criticize it, but one of the issues here is that this is really a violation of ADA subpart E, if you remember yesterday, which relates to communication. Because while a sighted person can tell visually through the color differences that we have two separate facilities here, that information is not communicated to a blind pedestrian because they can't see that color differential. And so from a accessibility and especially a safety standpoint, the question is, how do we kind of designate detectably so that someone with a cane can tell the difference, the bike facility from the pedestrian facility? And that's what I'd like to talk about briefly. I've added a few slides here, and also Mike has added another file to the chat. It's called Quick Overview of Tactile Walking Surface Indicators. So you can download those slides so you have these additional ones. But the general term for what we're talking about is tactile walking surface indicators. And you all are already familiar with one of these here on the left, the detectable warning surfaces, the truncated domes that are incorporated into ADA and PROAG. And there's standards for these in terms of the spacing of the domes, the dome height, the color contrast requirement, and so forth. But another less well recognized or understood tactile walking surface indicator is shown here on the right. These are called directional indicators, and notice they're slightly raised. And the idea is that a blind pedestrian can detect this with a cane, but yet it's not high enough that it would, say, trip an able-bodied pedestrian who walk across it, or it's not going to cause a loss of control for a bicycle that might ride over it. And so those are called directional indicators. They've been used in Asia and in Europe for many decades. More recently in the US, and right now there are no standards for these in the United States. Research is underway to develop those standards, but there are no standards. So I thought it might take just a couple minutes to look at those. One of the items, or one of the surfaces, I should say, that's apparently doing well in the research that's underway is what they call a raised trapezoidal surface. And you can see it's a raised kind of a plastic or composite material surface that's high enough that it can be detected with the cane, but also notice it's not so high and not so steeply sloped that it's a problem for a bicycle. Bicycles apparently can go over this without an issue. And there are some cities on the West Coast and in the southwestern United States that I believe have already implemented these. Here's an example of that first surface I showed you, that directional surface. This is the city of Philadelphia, one of their waterfront trails or projects. And notice here on the left image, you can see it's a sidewalk adjacent to a bike facility. And in the background, you can see there's some landscaping or grass strip. So obviously there's a detectable surface between the two, so that a blind pedestrian could identify that and not walk onto the bike lane. But notice here, maybe in the foreground, maybe due to right-of-way restrictions or something, notice there is no median or separation, and it would be easy for a blind pedestrian to just wander into the bike path with obvious safety issues or concerns about that. So they have installed these guidance surfaces here, you can see them, to provide that tactile indication to the visually impaired. And the right-hand image is just another section of this facility. You can see how they've installed it. And I should note that in both of these photos, these facilities are not yet complete. So you may notice some things that maybe are missing or not compliant. That is likely due to the fact that it's not completed yet. Another place on the left here where these directional surfaces come into use, and questions like this often come up at my ADA classes. Someone says, you know, we have a ramp that goes from a bike lane up to the sidewalk so that bicyclists can use the sidewalk rather than a roundabout. Maybe they feel more comfortable on the sidewalk. But the issue is, what about the disabled or the visually impaired, I should say? As a visually impaired person, notice if this directional surface wasn't here, they could walk right out into the street or into the bike lane. And actually, it would not be correct in my mind to put a detectable warning surface here. You do need a warning for the visually impaired, but if you had a detectable warning there, that would imply that this is a legitimate legal crossing point. But we don't want the visually impaired in the street at this point. But these directional indicators you can see here at the top of the ramp are where the sidewalks diverge. And I've just superimposed a white arrow there to show that. But this, someone with vision impairment using the cane, they can detect this and follow that to kind of guide their way around this, so they shouldn't go down that ramp. And the right-hand image is just a Google image I found from the city of Seattle. It's a pretty busy in the sense of a lot going on at this street corner. But notice where my cursor is here and here and here, this yellow, these yellow surfaces, these are the detectable warnings for the pedestrians. But you'll notice the bicycle ramps, which are the green color, have the same physical characteristics as a curb ramp. So a blind pedestrian could walk down that bike ramp and think that they were on a regular curb ramp, when of course they're not. They're in a bike lane. So notice what the city of Seattle has done. They've put the yellow guidance surfaces at the top of that bike ramp, and this one, although unfortunately this kind of tent sign here is blocking the use of it. But there's two examples of using these directional surfaces at bike ramps. So that was a quick overview. I know it's because it's a little bit off topic of what we're talking about, but if any of you are interested in more information, I don't want to promote our own program, but at the end of last year, I think November, I did a 15-minute flash webinar for the West Virginia LTAP on tactile walking surface indicators. And it's recorded, and the link is available on our website, and the link is also in the handout in the PDF. So if you want more information on this, my first suggestion would be go check out this flash webinar. It takes only 15 minutes of your time. And if there are more questions or concerns about this topic, maybe just in the interest of time, feel free to email me offline, and I'll be glad to try to address your questions or comments. And Eli, I hope this maybe answered the question that you had on Tuesday. But with that, we'll proceed back to the normal agenda. Last time, of course, we talked about the pedestrian access route. We talked a little bit about accommodating pedestrians. Today, we'll talk about how do we make up or create an accessible and detectable temporary path? What are some best practices? And then as time permits, we'll look at some actual temporary traffic control situations. Just a little review. Remember, PROAG talks about the alternate pedestrian access route. It does need to be accessible. And recall, to the maximum extent feasible, it should be on the same side of the street as the disrupted route. But one thing we didn't talk about yesterday is, notice PROAG says where pedestrians are exposed to adjacent construction, traffic, meaning vehicular traffic in the roadway, or other hazards, they shall be protected. Notice the shall, that's a requirement, with a pedestrian barricade or channelization device. And we'll talk more about those barricades and devices, but I wanted to bring that to everybody's attention. What sort of things do we need to consider in creating an accessible alternate pathway? I would look, for one thing, at the general environment, especially are there pedestrian generators in close proximity to the temporary traffic control zone, like schools, shopping areas, community centers, senior centers, transit facilities, those types of things. Or for example, maybe in the neighborhood where you're going to be working on the sidewalk, maybe on one corner is a senior high-rise housing facility, and maybe 2 blocks away on the same side of the street is a Walgreens or CVS or something like that. We can kind of predict that there's going to probably be pretty good movement of older elderly pedestrians between that senior housing facility and a pharmacy. So those are the sort of things we want to look for. Also look at traffic characteristics, the speed of traffic, the volume of traffic. Not only say over an average day, but also maybe peak hour volume characteristics. And also, do we have a significant presence of trucks or buses, large commercial vehicles? I think we talked about this, both PROAG and the Mutcd talk about same side travel is preferred, both due to distance considerations, but also safety considerations. And I think we talked about this yesterday as well. Depending on traffic characteristics and the surrounding environment, a route that uses one of the vehicle lanes or parking lanes for the pedestrian pathway may be shorter, safer, and more usable than one that requires pedestrians to cross to the other side of the street and then a block or two later cross back to their original side of the street. Remember, pedestrians are not likely to backtrack. By that I mean able-bodied pedestrians. And you see that in the image here. This is a mid-block sidewalk closure, and rather than backtracking to the corner, which I think is what the sign says, the pedestrians are in the street. But remember, we're here to talk about those with mobility or vision impairments, and they'll have to backtrack because a blind pedestrian here really doesn't have any guidance where to go. They'll be able to identify that curb, but they probably also realize they're in the middle of the block and they don't want to step off the curb in the middle of the block. So they'll have to walk back to the corner and try to figure out how in the heck do I get to my destination by some other alternate route. And someone in a wheelchair, a manual wheelchair, has just kind of wasted a lot of energy to get to this point, and then they have to turn around and retrace their path and get back to the corner. So early warning of what pedestrians are approaching or closing sidewalks at the beginning of the block rather than mid-block can be helpful. What about if you have areas where there's few or no pedestrians? Well, under PROAG, that alternative pathway still has to have the same level of accessibility as the one it's replacing. And keep in mind, there should be no curbs or abrupt changes in grade or terrain that could be a tripping hazard or a barrier to wheelchair use. Now, question sometimes comes up in these classes. What if I don't have a sidewalk? And what if it's on the outskirts of town? Do we still have to comply with all of these requirements you've been talking about? And my advice is, if there's no sidewalk or no wide shoulder where people walk, or no evidence of pedestrian activity, that you can't see a goat path in the grass where people have been walking, the project may not require an accessible alternative pedestrian route. But I would say if you're going to do that, meaning if you're not going to have a accessible route, be sure to document why. Like maybe you might note, well, I was out there a couple in the month before the project actually was implemented. I was out there doing a pre-construction survey or marking utilities or whatever it might be. And I was there an hour each time and I never saw a pedestrian. Or I probably would even take photographs of the grass along the roadway to show that there's no goat path in the grass. And then we don't need all these accessible alternative route requirements that we're talking about. But what I would also probably do is have somebody on the crew designated to be on the lookout for, and if they see mobility impaired pedestrians, say someone in a wheelchair, to be able to assist that individual and get past the work area. Because I am always surprised, I probably shouldn't be surprised, but as you all know, West Virginia is a relatively rural state once you get outside our built up urban areas. And I've been on some really low volume, traffic volume secondary roads in the state and come around a corner and there's someone in a motorized wheelchair kind of scooting down the road. And that's great for them. But my point is sometimes even when we least expect it, there may be a mobility impaired pedestrian in the roadway. So we need to, even if we're not providing facilities, provide some sort of arrangements that if somebody does show up or appear, that we have a plan to get them around the work area. Also keep in mind that we need to provide access to businesses, and we may have to have sort of ramps or bridge type structures to get folks from a sidewalk or street into a business. Transit stops need to be maintained, or if they're relocated, need them to be accessible. So we need to work with, we being those in public works, need to work with transit agencies in that regard. These are the components of an accessible, detectable, temporary path. And this is what we'll talk about over the next little bit. We'll talk about detectable edging, as it's called. We'll talk about pedestrian channelizing devices, although we also will mention vehicular channelizing devices, but the focus is going to be on pedestrian. We'll talk about pathway width and surface a little more. We touched on that Tuesday. We will talk about temporary ramps. I think there was a question or two last time about temporary ramps. We'll also talk about sidewalk closures, and we will look at audible devices, including human beings. Just a reminder, I think I mentioned this yesterday, but not only did I say it, but notice the Mutcd prohibits the use of tape or rope or plastic chain or the like strung between devices because they're not detectable and they don't comply with either ADA or PROAG. But yet I continue to see this a lot around the country. So we need to be moving away from the use of this yellow caution tape all over the place in temporary traffic control zones on sidewalks. So detectable edging for pedestrians. So this comes from the Mutcd, section 6F.74. And you can see it should be provided throughout the length of the temporary path. The edging should protrude at least 6 inches above the surface of the pathway, with the bottom of the edge a maximum of 2.5 inches above the surface. And then finally, they should be firmly attached to the ground or to other devices. So let's look at some examples. And also they should be, notice it should, it's not a requirement, but they should be orange, white, or yellow and should match the color of the adjacent channelization devices or traffic control devices, if there are any. Some examples. There's prefabricated lightweight sections of plastic, metal, other similar materials that are interconnected and fixed in place to form a continuous edge. That's what we want, is a continuous detectable edge. Could be sections of lumber interconnected and fixed in place to form a continuous edge. It could be formed in place asphalt or a concrete curb kind of arrangement as well, as long as it's, has that kind of vertical detectable edge. And I don't know if anyone's seen this, it's not that common, but I have seen it occasionally. Normally, chain link fence is not considered a detectable edge, but there are some companies that make kind of a chain link fence type of arrangement that has a bottom rail of plastic or wood that forms a toe board or detectable edge at the bottom of that fencing. So all of these things, and there's probably others as well, but these are examples of detectable edging. Here are a couple illustrations. Let's start with the left side. And I think someone last time asked about the netting, so I'll say a few words about that. But let's say this sidewalk, I haven't measured it, but let's say it's 5 feet. So it's wide enough for an alternate path. Looks like they're just narrowing the sidewalk. And I don't know the dimensions of this lumber here at the bottom, but let's assume it's 6 inches. If this is 6 inches or more, and it's firmly attached to the ground and to each other, I would say that meets the requirements of the detectable edging. If it's less than 6 inches, it does not. So for example, you couldn't use a 2x4 there because you're not going to have 6 inches vertically by just using a 2x4. Notice the netting here, this plastic netting. That in this arrangement, I think is acceptable. If we just had the netting sort of hanging down from an upper rail to the bottom and there was no toe board or kick plate or edge down here, that would not be acceptable because that would not be a detectable edge. But having said that, the one thing I would caution is if you're going to use an arrangement like this, make sure that periodically you check the tautness or tension of that netting. It's hard to tell, but here in the lower right, it kind of looks like it may be starting to sag or droop a little bit. Same thing back here. And one thing that can happen with that netting in this, where it's close to the ground, is someone's cane can actually get tangled up in that netting. And obviously that's not a good thing. So you'd want to make sure if you use this arrangement, or if one of your contractors does, make sure that somebody's checking to make sure that that stays taut to reduce the likelihood of a cane getting tangled up in the netting. But I mean, this to me is kind of good. These can probably be reused on other projects around the city or the area, and it appears from what we see to comply with the requirements for edging. How about on the right here? Let's say this is 5 feet. I'm not sure it is, but let's say the walkway is 5 feet. And personally, I don't think this board down here is 6 inches vertically. So that's not considered edging. But let's assume that it is. I'll just ask everybody, let's assume this is 8 inches high here, 8 inches vertically. So we have a 5-foot walkway, which complies with PROAG. We have an 8-inch sort of toe board down here, which complies with the edging requirement. There's also an upper rail. And so to me, this would comply with PROAG. But I use this example to illustrate that PROAG is an accessibility standard. It's not a safety standard. We still have to use our training, our education, our knowledge, our experience to build safety into these projects. Would everybody agree with me that while this may comply with PROAG, if this is 8 inches down here, I would argue this doesn't comply with just general construction safety practices. To me, you wouldn't want to leave something open like that. A child or anybody could get into that work area and be injured or harmed or something like that. So while this may comply with PROAG, I hope everybody would agree that doesn't really comply with good, just kind of common sense, general construction safety practices. So that was edging. Now let's look at channelizing devices. These are vertical, sturdy, and have a smooth, continuous surface, free of sharp or rough edges or objects for what I talked about last time, or I called hand trailing. So let's look at these devices in a little more detail. Now here we're looking at the MUTCD section 6F.63, and the manual says devices used to channelize pedestrians must be detectable to users of long canes and visible to people with low vision. So those two categories of vision impairments. There must be a continuous detectable bottom and top surfaces to be detectable to cane users. The bottom of the bottom surface must be no higher than 2 inches above the ground, sorry. And the top of the top surface shall be no lower than 32 inches above the ground. So no higher than 2 inches above the ground to the bottom of the bottom surface of the device, and the top of the top surface no lower than 32 inches. And no part of the device may extend more than 4 inches into the pedestrian pathway. And remember, that's that protruding object requirement we talked about last time in the pedestrian access route, because this can cause harm. It could also cause a wheelchair to get stuck or overturn, or it could trip a visually impaired person, or cause somebody using a cane to be disoriented. Or as we talked about last time, not only are those with disabilities affected by this, but a protruding object can also injure or harm a sighted or able-bodied pedestrian. And here's an example of a compliant channelizing device. Notice a common vertical plane, no protruding objects into the walkway. And if we put these side by side, there should be a continuous barricade, and the gap between the bottom of the unit and the ground is less than 2 inches. Here are a couple more possible channelizing devices that comply with the requirements we talked about. The one on the left we'll call a longitudinal channelizing device. I probably would add the word pedestrian there. Longitudinal pedestrian channelizing device. And notice the maximum that it's off the ground is 2 inches. And there is that 6-inch kind of vertical surface there. The total height, 34 to 38 inches. On the right, we see a type 2 pedestrian barricade, which appears to comply with the requirements we just talked about as well. How about this? Does this look to be compliant? This looks to be a building construction project rather than, say, a public works project. But notice the sidewalk is closed and pedestrians are detoured. Looks like a temporary ramp here, and then into a pathway in the street, or maybe across the street. Is not really clear, doesn't matter. But I would say this is not compliant as a channelizing device. That, would we all agree, that's more than 2 inches there between the bottom of the device and the sidewalk surface. So that is not appropriate as a channelizer for pedestrians. How could we make it a channelizer? We could do something like this. Notice this agency has added a board here at the bottom of the type 3 barricade that would be less than 2 inches off the ground and is detectable with the cane. A couple things I would note. Notice one thing, the feet of this type 3 barricade project into the walking area, and that may be a tripping hazard for pedestrians. The other thing I would note is that we have taken what had been a crash-worthy type 3 barricade and added this board to it. So from a motor vehicle standpoint, this would not be a crash-worthy device. But I would say as long as it's being used, let's say in this application here, on the sidewalk where it's not likely to be struck by a motor vehicle, that should be okay. But keep that in mind if you'd be locating this near the traveled way where a motor vehicle that departed the roadway could strike this, recognize that that would not be a good situation because this is not a crash-worthy device from a vehicular standpoint. How about this? Similar arrangement, not exactly the same setup, but notice this part of the sidewalk is closed. They want pedestrians to walk under the canopy, and they have put a board here that serves as that channelizer to assist the visually impaired into finding the alternate pedestrian access path. So just as a summary of the channelizing device requirements, it should be cane ready, meaning a continuous smooth lower rail that's detectable by the cane. Should have hand trailing capability, meaning a continuous smooth upper rail that's free of rough surfaces or nails or splinters, that type of thing. Should be obstacle free, no protruding objects into the pathway. And the connections need to be smooth to provide continuous guidance. There shouldn't be gaps between the devices. And here's what I mean by hand trailing. Notice these channelizers form the path there. Hope that's 5 feet wide. It should be at least 5 feet wide. But notice this pedestrian just kind of running his hand or her hand along the top of the barrier there, or the device. So you want to make sure, as I said, and this one, since it's a commercially available one, that shouldn't be an issue. But if you build your own rails out of lumber or something, make sure that it is a smooth, continuous surface. Another issue with these is color contrast, which is mainly important for pedestrians with low vision. So it's something to take into account when you are selecting devices. It's recommended that orange is a good color, although there's no standards or requirements in this area. But orange, of course, does seem to be kind of the standard color for construction. It does provide good contrast with white, and usually does not result in glare. Also, one other thing to keep in mind, I would avoid using black to color any base on a device. And I'll show you an example here towards the end of the session. But that black can blend in with the pathway surface, and especially at night or dusk or dawn, low light conditions can create a tripping hazard, not only for the disabled, but also for able-bodied pedestrians. So just, again, there's no prohibition or anything in the manual or in PROAG, but just, I think experience shows it's probably best to avoid the use of black to color any base. Again, these are longitudinal pedestrian channelizing devices. And I want to emphasize again, these have not met the crash-worthy requirements for temporary traffic barriers. So if your traffic control plan or other requirements call for positive protection for pedestrians or workers, these are not the devices to use because these do not provide positive protection from intrusion by motor vehicles. These are not crash-worthy barriers. If you want positive protection, or if positive protection is required by the plans, this is what needs to be used. We need to use temporary traffic barriers. I call them TTB. These are devices that are designed to prevent penetration by vehicles and should minimize injuries to workers and pedestrians as well as to motor vehicle occupants. And these barriers, these are not the only ones that you see here. These are just an example, but all temporary traffic barriers are required to be crash worthy. And also, it's probably a good idea to supplement those TTBs with standard delineation, pavement markings, channelizing devices, some form of retroreflectivity, so that they are clearly visible at night to channelize vehicular traffic. Well, day and night to channelize vehicular traffic. So here's a what do you think? I took this a couple years ago, I guess just before COVID. I was at a conference in this city And so I was not involved in this project, but I'm sort of speculating what happened here. You can see it looks like for a while, because you can see it's well marked here, it looks like they had a continuous line of temporary traffic barriers, the concrete barriers here to separate the pedestrians. This is the pedestrian access route. You can see the base of a temporary ramp here. And this, of course, is a multi-lane, looks like arterial roadway. The project, a building construction project, appears to be to put in a high-rise steel frame building. And I'm just guessing, but I'm guessing that while they were excavating the foundation, this area consisted of that line of concrete barriers. And then at some point, maybe I'm thinking they probably needed to have trucks, maybe flatbed trucks, access this area. Perhaps they were bringing in steel or concrete panels or something. And so maybe I took this photo probably around 7 o'clock in the evening in the summertime. So maybe earlier that day, there had been some flatbeds in here and they were unloading steel. And maybe there's going to be more trucks back in the morning. So it's probably not appropriate to put the concrete barriers back here for just a few hours. But on the other hand, I would argue, notice these tubular markers, fairly widely spaced, are not a detectable barricade here, or not a pedestrian channelizing device. I think, and if you look at, those of you familiar with Part 6 of the MUTCD, I believe these tubular markers are in the channelizer section, but that's referring to motor vehicles. These are not a pedestrian channelizer device. And also look at the exposed end of this concrete barrier here. Remember, traffic is coming from the back of the slide to the front here. And so that is a potential serious roadside safety issue. If a vehicle would depart the road and run into that exposed end like that, that would result in serious injury or fatality, perhaps even. So this is one of the challenging problems. I'm not proposing they should put the concrete back here for just a few hours, but yet they do need some sort of detectable surface. Maybe the pedestrian channelizers that could be relatively easily moved out of place, when the trucks return the next morning. But it's going to depend on probably on more than what we see here. But the point is, what you see here is not an appropriate pedestrian channelizer, and it's not safe for motor vehicles either. Also note that without external steel rails or internal steel framework, the water-filled longitudinal channelizers do not have the capability to redirect vehicles. So can't just substitute them whenever a barrier is specified. And another thing to think about with the water-filled barriers is their deflection characteristics, meaning their movement when they're struck. Usually precast concrete barriers have lower deflection, lower movement, and plus you can pin those in place. So you definitely would have positive protection for pedestrians or workers behind those barriers. And here are a couple examples, just again to clarify things. Some of you may recognize this. This is typical application 28 from the Manual and Uniform Traffic Control Devices. I kind of rotated it 90 degrees so it fits on the slide better. But notice this is a sidewalk closure, maybe for some building construction project, and the pedestrians are being rerouted into what had been the parking lane. And what I wanted to point out is these orange devices here, these are pedestrian channelizers. They are not the TTBs. They are not a traffic barrier. But it looks like this is in town. We see city blocks here. It's a one lane in each direction roadway. So probably a low speed situation. So I think that's appropriate. But again, I just wanted to point out the manual here is pointing out pedestrian channelizers, not traffic barriers. This page and the next slide that you'll see, I took from the Minnesota DOT Temporary Traffic Control Manual. And notice this is for a low speed roadway, like we just talked about. And notice they're showing a sidewalk here, and then the orange and white indicate pedestrian channelizers. So they're channelizing the pedestrians to a temporary ramp. And notice even between the vehicular traffic and the pedestrians, because it's low speed, we have a pedestrian channelizer. And then they call it minor road. If it's in town, this might be an alley or something like that. But notice, because the walkway, the alternate path here, crosses a roadway without any curb, we need to have detectable warnings. So that's what this black and yellow symbol is showing here. Need detectable warnings to indicate to the visually impaired that they're crossing a roadway. And then they'd go up the temporary ramp, and the channelizers would help direct them back to the normal sidewalk situation. Now this one is slightly different. Notice here we're talking about a high-speed roadway or low-speed multi-lane. So multi-lane roadway or high-speed two-lane roadway. Again, this is from the Minnesota DOT. Notice channelizers used to direct pedestrians to the temporary ramp. But now notice separating the pedestrian path from the vehicular traffic are the temporary traffic barriers, the concrete barriers, the crash-worthy barricades. And of course, as we just mentioned, the ends of these are a hazard for motor vehicles. So they have, looks like crash cushions here to shield that exposed end. And then pedestrian would go up the temporary ramp, and the pedestrian channelizers would direct them back to the sidewalk. And I think someone asked yesterday, maybe, do we need detectable warnings at the base of ramps? And the answer is the detectable warnings are needed only if the curb is missing at a street crossing. If there's no conflict with vehicles, you don't need detectable warnings at the base of the ramp. And so notice here, the pedestrians, or I would say, are in a zone of safety. They've got the pedestrian channelizers here, shielding them from the construction activity. There's temporary traffic barriers on this side, shielding them from vehicular traffic. So as long as they're in this corridor here, or this path, the temporary path, alternate access route, there's no danger of conflict with vehicles. So we don't need detectable warnings. And if you allow me to back up here, sorry about that. Notice this one, the first one I showed you from Minnesota. Notice there are no detectable warnings at the base of the ramp because there's no traffic conflict there. The traffic conflict comes at this alley or minor road, and so that's where we have the detectable warnings. So I hope that answered that question, the question that came up Tuesday. If not, please clarify or expand your question, and Mike will let me know. And so this is, again, this is the high speed or low speed multi-lane where you need positive separation between the pedestrians and vehicular traffic. Pathway width we addressed yesterday, but it helps to review. Remember that under PROAG, the minimum continuous clear width of 48 inches must be maintained. More than that is recommended, and as I said yesterday too, probably many of your agencies may use 5 feet as the minimum, and that's fine. You can go above and beyond PROAG. But keep in mind, for those of you that rely on PROAG, where the clear width is less than 60 inches, you have to provide passing spaces, 5 foot by 5 foot passing spaces at intervals of a maximum of 200 feet. Surfaces, I think we talked about that a little bit yesterday too, but it bears repeating and discussing that today. The walkway surfaces must be smooth, stable, and slip resistant. The path should be able to support a wheelchair under all conditions. Notice the photo on the left. Someone sent me this a few years ago and claimed that this was an accessible temporary route for their project. And I responded that no, it's not. Maybe on this day, looks like a dry winter day, maybe the ground's even frozen, maybe a wheelchair could go over that on that particular day, but it's not always going to be like that. You get rain or spring thaw, that's not going to be traversable by the wheelchair. So it needs to be traversable under all conditions. And make sure the path drains well and that you check for standing water and sediment and so forth after rains. The photo on the right here I took in Washington, D.C., actually just before COVID. I was in town for a conference. Notice they have a nice wide, that looks like almost 10 feet wide, pedestrian path here, and they have the temporary traffic barrier separators here, because this is, you can't see it, but it's a multi-lane street. I don't really like the way because there's really no good guidance or edging to me to get pedestrians to the sidewalk. This was an existing curb ramp. Actually, it's not compliant with PROAG because this is all sidewalk. And so it needs to have flared sides, not vertical curb return sides. But anyway, the key thing I want to point out is notice there's a big drainage issue here, a lot of standing water. And that's, just kind of a nuisance to all pedestrians, especially if you're in a wheelchair. The wheelchair wheels throw up the water onto your coat or clothing or whatever. And actually, the day I was here, just after I took this photo, a fellow in a business suit, dress shoes, showed up, and he attempted to jump over this water. And actually, I guess because of some of the sediment and things around here and the wet pavement, he actually lost his balance, and another pedestrian sort of reached out and grabbed him to prevent him from falling. So my point is, there's a case where even a able-bodied pedestrian experienced some safety issues at something like that. So try to pay attention to the standing water and sediment or mud at the base of your ramps. If you have any joints in the walkway, those joints should be closed and flush to prevent tripping or prevent the chance of a cane or the small front wheels of the wheelchair getting caught in those gaps or spaces. Yesterday or Tuesday, we talked about grates. If you have grates within your route, pay attention to the opening width and the orientation of those grates so as not to create a safety issue. In addition to water, I think make sure your paths are clear of debris and sediment. And keep in mind that continuous edging that you can follow, that someone can follow with the cane throughout the length of the facility. How about this? Not very good. To me, this looks like a lawsuit waiting to happen. Notice if you look at the far right, this existing building or storefront here, this wall provides a good shoreline for the visually impaired. So that's good. There is some edging there, if you will, if you want to call it that. But how about here in the center of this sidewalk, these drums, which looks like they're maybe, I don't know, what, 6-8 feet apart, that is not a form of edging or channelization. There needs to be some sort of edging here that provides a shoreline on this side of this walkway. And then I'm not sure why they didn't have some sort of barrier or edging or channelizer here to keep pedestrians out of this area, because this, to me, is a danger for both able-bodied and disabled pedestrians. I'd want to put some positive separation there to keep pedestrians out of that area. Temporary curb ramps. I've mentioned those a few times already. Let's look at them for a while and see what's required. They should be the full width of the temporary route, meaning if you have say an 8-foot route, then your ramp should be 8 feet wide. But the minimum width, of course, would comply with, or would be according to PROAG. The ramp should be in a single sloped plane with a minimum of warping. And typically we don't talk about handrails on curb ramps. I'm not sure I've ever seen a handrail on a curb ramp, say at a corner, but with temporary ramps, notice, and I've italicized it to kind of highlight it, for temporary ramps, if the ramp has a rise exceeding 6 inches and the length exceeding 72 inches, we do need handrails on the temporary curb ramps. So just something to keep in mind. Of course, the ramps need to be firm, stable, and slip resistant. They shouldn't warp or buckle. And remember, it's not just pedestrians or people in manual wheelchairs. Some people have what they call the power chairs, the motorized chairs, which can weigh considerably more. They should be color contrasting and have a marked edge on both sides, so they're noticeable by pedestrians who have vision impairments, low vision pedestrians. The entry onto or into the ramp in both directions should be flush and free of abrupt changes. Remember, we talked about Tuesday, changes in level between 1/4 and 1/2 inch need to be beveled with a slope not greater than 1 to 2 or 50%. And of course, we need a 4 foot by 4 foot or 5 foot by 5 foot turning space at the top and bottom of the ramp. And here's a couple examples. I call these poor ramps. Let's start on the right. This looks like a homemade ramp, which is fine. I mean, I don't mean to discourage people from building their own ramps, but they need to comply with the criteria. This agency put in a nice railing here, or guard, whatever we want to call that, and that's a good thing, except remember, when you have a guard or railing like that, that creates what we called on Tuesday a constrained condition, meaning the footrests on the wheelchair cannot go beyond the edge of the ramp. And so in that, or the edge of the landing here, in that case, this turning space needs to be 5 feet by 5 feet. And just visually, it looks to me like that's not 5 by 5. So I don't think there's enough space there for someone in a chair to be able to turn to go up and down that ramp. And then how about the one on the left? This violates a lot of what I talked about. Notice how that is bowed or warped. Just doesn't look like it's going to handle much of a load. And because of the way it's warped, notice how the edges are way off the ground, certainly more than 1/2 inch or 1/4 inch. And it may make it tough for the small front wheels of a manual chair to even get onto the ramp, or it may be a tripping hazard for other pedestrians. And this is the fellow in the chair here is Scott Windley. Scott is with the Access Board, the U.S. Access Board in Washington, and he certainly is not about to go down that ramp. He's just illustrating some of the considerations here. One time I presented with Scott, and he mentioned at that time that the batteries of his power chair here, the batteries alone weighed 400 pounds. So if you think about the batteries weighing that 400 pounds and then the weight of the chair and then Scott's weight, I mean, we're talking probably 600 or 700 pounds or more that the temporary ramp has to support. And I sure don't think that's going to be able to support all of that. So these are the things we need to keep in mind, as I've mentioned. But then further here, notice, I like the way that somebody maybe got a skid steer or something in here, and it looks like they tried to clear the snow from the pedestrian access route. That's a good thing. But on the other hand, notice they didn't clear it from around the base of the ramp. And maybe they didn't because there's not 5 feet there for someone to turn. So this is a turning space at the base of the ramp. That needs to be, in this case, because it's constrained, it needs to be at least 5 feet in the direction of travel. That, to me, that looks like 2.5 or 3 feet. Maybe that's why they didn't clear the snow, is they knew nobody could turn there. But that's a real issue. That basically makes this ramp unusable if somebody can't turn to continue on the walking path once they go down the ramp. So a lot of things to consider in that image. Not trying to promote a particular product or anything, but as many of you are probably aware, there are commercial temporary pedestrian modular type ramps that can be purchased. And notice this one has a hinge portion here, so it kind of can come down and bridge over any openings. This is, I think, about 1/4 inch thick here, so it doesn't create much of a lip. Remember, a 1/4 inch vertical is allowed under PROAG. Notice it has edging here at the base of or at the edge of the ramp, and then notice it has handrail as well. And also notice here this flips down with the hinges there to create a beveled surface to enter or leave the ramp. And this folds up. I think it weighs like 400 pounds, but it folds up and can be reused on other projects. So if you're from an area or community or agency that gets involved in a lot of temporary ramps like this, might want to consider acquiring some of these. Here are some I just photographed in my travels. Let's take the one on the lower right first. Again, it looks like a homemade ramp, which is fine. They have guard or edge here. The only thing I don't like is, and it looks like this is 5 by 5. It looks wider than that one I showed you earlier. But notice here, there's a significant lip. I don't know what the thickness of that plywood is, but I think that certainly exceeds a 1/4 inch. They did try to highlight it, I guess, to prevent tripping incidents, but still that would be a barrier for a wheelchair. How about the upper left? To me, this looks like one of those ramps that steel ramps or metal ramps that maybe soft drink delivery people, beer delivery people have on their truck that they can help them get in and out of certain locations that may only have steps. I'm not sure how wide it is. This may not be compliant in terms of width, but notice they did put a beveled edge here. It does have kind of a low guard here. They did paint some yellow stripes at the edges here, and it looks like they applied some sort of friction strips or skid resistance here. So this may comply with PROAG. I'm not really sure. I didn't measure it. But a bigger concern of my own about this situation is notice what happens at the bottom of the ramp. This looks like a work area or a detour path along a multi-lane arterial road, but there is no channelizing devices, no edging, nothing to help even a sighted pedestrian know where the path is or to separate them from higher speed traffic. So again, we have to consider all the things, not only the ramp itself, but where is that ramp sending people? Like we looked at in the previous slide, where if Scott had gone down that ramp, there wasn't sufficient space for him to turn at the base of the ramp. Here there's plenty of space, but there's really no detectable path of where a pedestrian should go and no separation from moving traffic. And here's Scott again. This is another work area. There is a set of concrete temporary traffic barriers here outside of the view of the photo. Normally, if you look at various textbooks and guidelines and things, they will say that we should not build what are called built-out ramps. Notice this ramp is built out from the walkway into the street. One reason for that is that they may create drainage issues. At least here they did put a pipe in underneath the ramp. Also, sometimes these may be tripping hazards for pedestrians. But I think it illustrates one of the things about ADA is we sort of have to keep an open mind, because sometimes things that we would say, I don't want to use those in a permanent setting, and that would be good advice, but they may have applicability in a kind of a temporary situation. And I think that's the case here. I too am not a proponent of built out ramps. I suggest people don't use them. But in this temporary application, this will probably be here maybe a couple or 3 months, and there's no vehicular traffic here. I mean, I think this is probably a okay use of a built out ramp. I don't really have a problem with that. I probably would put some, even if it was just painted yellow stripes on the edges of that ramp just to help delineate it for all pedestrians. But the general concept of a built out ramp to me is okay in this environment or this situation. How about this one? See a lot going on here. Notice the sidewalk is back here. So what's that? It's maybe 10 feet back from the street. So we have a wide grass strip or tree lawn here. This is probably a building construction project, not a street or road project. Of course, grass is not an accessible surface, so they've built a boardwalk across it. They've actually put a railing in here, which I think is good. And that's probably okay. If it was my project, probably I would put a tow board or kick plate down here as well. That's detectable. And then they have the separation from traffic. They're using temporary traffic barriers. That's good. But recall, these need to be interconnected and interlocked. These are not. So these are not going to probably behave as a crashworthy device. So these need to be interlocked and connected and continuous with one another. Notice there is a ramp here. I'm not sure why they didn't square it off, but there is a ramp, and notice there is a good lip here. They tried to highlight it with some orange spray paint, I guess, but personally, they need to put some sort of beveling or asphalt wedge or something in there, because that is too much of a lip, in my opinion. And notice, because this ramp is separated from vehicular traffic and the pedestrian is not crossing vehicular traffic, we don't need a detectable warning surface at the base of the ramp. This is fine without the detectable warning. In fact, a detectable warning would actually confuse the visually impaired, because they would be expecting a street crossing. In some cases, we may need to have covered pathways or canopies. If you have work activities taking place above a sidewalk or walkway for an extended period of time, need to provide some sort of protection from falling objects. And here's a case where you do get some differences between the Mutcd and PROAG. Those of you familiar with Mutcd know that they talk about signs in urban areas, pedestrian areas, having a minimum of 7 feet between the sidewalk or the ground and the bottom of the sign. And so that same rule would apply for overhead protection. PROAG says 80 inches. And again, keep in mind, especially when you're leading pedestrians under these canopies and things, keep in mind the protruding object requirements we talked about. And here are some examples. We might start in the left and then we'll go clockwise. Obviously, there's overhead work going on here, potential danger of falling objects or debris, and so they have a covered walkway for pedestrians. Here in the upper right, this looks like they have taken one of these intermodal shipping containers and cut the front and back out, cut some windows in it. Hopefully they've strengthened the roof, because usually it's just sort of light gauge steel, I think, for the most part for those trailers. So you'd need to stiffen the roof in terms of falling object protection. Notice they've added some lights. They've added a tow board or kick plate here. They've added a handrail. I kind of like that, although last time I taught this class, someone commented that their agency had tried this, and apparently they had issues with the access to the trailer, because of course the trailer does have a steel frame, and they indicated they had some issues with the ramps going up to and down from the trailer, but just something you might think about. So those are both urban area projects. The lower one is a more rural project. This is actually the C&O Canal, which is a historic facility basically between Western Maryland and Washington, D.C. Draws a lot of walkers and bicyclists. And this is a Maryland State Highway Agency bridge. As I understand it, it's closed for a couple years, or vehicular traffic, I should say. It's just down to one lane, while they replace something like 150,000 bolts or something. So obviously there's a danger of bolts or the hand tools involved falling onto the trail. So they have, you can see the trail was fairly wide under the bridge. They have now created a more narrow, but more than 4 feet wide pedestrian access route with overhead protection should there be falling objects from the structure. The only thing I don't like about this is how they have the entry to the the bridge. I should note the main trail is over here, but there's also a spur trail that connects to a local community that comes in here. So this is actually a trail intersection. And I think if it was my project, I would put in some edging or a barricade here that is detectable. You can see they have a sign, but remember that sign doesn't communicate with the visually impaired. And here's another application of the netting, plastic netting, but notice in my mind this is not appropriate because this netting is just hanging from a board or frame that's been placed across here. There is nothing at ground level, no edging that we talked about earlier. So this application of the netting, in my opinion, is not appropriate. It doesn't provide detectable guidance to the visually impaired. Handrails and guide rails. Handrails assist ambulatory disabled pedestrians, helps them navigate steep grades along walkways. They are used to maintain balance, transfer weight, and prevent falls. Guide rails are not intended to provide support, and they really just provide a visual and tactile guidance to pedestrians. With handrails, there are specific requirements. You can see them here. I won't go over all of those. Also, ADAG has structural strength requirements. So recall, most of what we've been talking about is PROAG, but when it comes to, for example, handrails and the structural strength, we need to look to ADAG for those requirements. And guide rails, it's important for users to be able to distinguish between the guide rail and the handrail, so they're aware that the guide rail is not a weight-bearing device. We don't want them leaning on that thinking it's going to support them because it's not intended to. And this can be accomplished by allowing the guide rail to be kind of semi-flexible or have a non-rigid mounting or be of an ungraspable shape. And generally, the use of guide rails is limited to routes that call for what I'd call special guidance through turns or curves or crowd directional control, maybe at a special event. Next item is sidewalk closures. And notice that the MUTCD says that when we have a closed sidewalk, a detectable device shall be placed across the full width of the closed sidewalk. So something like this is not appropriate. This is a violation of subpart E. You have to be sighted. You have to have good vision to be able to see that sign. So to make this MUTCD and PROAG compliant, we need some sort of barricade across here as well. We can use the barricade and the sign, but the sign alone is not sufficient because it doesn't communicate with the visually impaired. How about this? This is better in the things I've just been talking about. Notice readily visible barricade here, or channelizer, pedestrian channelizer, bright colors, good detectable surface near the sidewalk, a sign for the sighted pedestrians. But to me, that's about as far as it goes in terms of good practice. Notice there's still a curb people have to step up and down to get to and from the street. So that's not accessible. And notice there is no separation in the street between pedestrians and motor vehicles. So I'll say they got 1 out of 3 right here, but that's not really a passing grade. Communication devices, audible devices. There may be times when what's going on with the detour or the sidewalk is maybe more complex than can be conveyed through devices. So you may need some audible information. And that's what you can see what the MUTCD says. So we don't always need audible devices. It's just that if the devices themselves, the channelizers, the edging and so forth, can't provide enough information, or if it's a complex setup or something, we may need audible devices. The message should try to clearly state the instructions on accessing the detour route, such as the message you see here. Attention pedestrians, sidewalk closed 1 block ahead. cross here to use the other side of the street. What about the devices? There are devices such as the one on the left and I guess on the right that detect motion, and then when they detect motion, they play a pre-recorded speech message saying something similar to what you saw on the previous slide. And these devices can operate continuously, or as I said, they can be motion sensitive, or it can be a push button arrangement like you see, I think, in the right-hand image. But I should note, if you use a push button arrangement where the pedestrian pushes the button to get the information, you need to have a locator tone, an audible locator tone, to let the blind pedestrians know that there is a push button available. And then one other form of audible device we should not forget is the human being. You know, in those of you that do work zones all the time in streets and roadways know that we don't want our flaggers communicating with motorists, or they shouldn't be conversing with coworkers. But on a sidewalk or walkway project, the human being can be a source of audible information. And so the term given to that is guides. They can be stationed in advance of the work area, and they can assist disabled persons, or really any pedestrian, in navigating the accessible pathway. And the photo shown here, this is the other end of that project I showed you on Tuesday on Canal Street in New Orleans. And I was here about 15 minutes just checking things out and taking photographs. And unfortunately, this individual, who I believe his job was to be a guide, he never turned around to even look at me or other pedestrians in the area where I was. So if you have a guide like that, they need to be instructed that their main job is to look for and assist pedestrians, not to be sort of the construction superintendent solely focused on the work activity or the project. And of course, we probably should communicate with the public, with residents in a neighborhood that's going to be affected, or businesses or schools, on major projects, long-term projects, heavily used facilities. May want to even think about a project website that addresses the pedestrian issues and accessibility issues. So what are some kind of best practices and things to consider? Especially on longer term projects, larger scale projects, I would like to suggest observing pedestrian travel and their patterns so that we can make accommodations for that in the design of the temporary traffic control. Same way, get input from local pedestrians, including people with disabilities, on how the devices are going to be placed and the lengths of time of closures and that sort of thing. They may be able to provide helpful information. Or one thing I also like to recommend is put yourself in the pedestrian's shoes. You or somebody working under you, get a cane, blindfold yourself, and kind of walk through the project as a blind person would, and see if there's any issues. Or same thing, you know, get a wheelchair. Manual wheelchairs are relatively inexpensive. Go through the project, the path. If the front wheels of the wheelchair leave the ground a lot, that's not a good thing. That means you need to relook at your cross slopes and surface and so forth. Always try to prioritize routing through the existing area, through the same side of the street if we can do that. But if not, maintain safe and accessible routes around the project or to the other side of the street. Or in extreme cases, if you have a long-term project that maybe the detour route is 2 miles or something, you might want to think about setting up a van shuttle service or something. Because again, remember, the ultimate or the bottom line for agencies is provide accessibility to the maximum extent feasible. May need to think about phasing construction. In this location that you see in this image, the project is actually on the other side of the street. So the sidewalk on this side of the street is going to be the detour route, but it was not accessible. So the first phase in this project is to reconstruct this sidewalk so that it can be made accessible and be used as a detour route. This is kind of sad actually here. Work on only one side of the street at a time. Notice in this city, it looks like we have a building construction project closing the sidewalk on the right here, and a street department or public works project which closed the sidewalk on the left side. And so this street is now totally inaccessible. And I'd be concerned about a ADA suit in that case. Probably, I suspect the businesses are not very happy either, or there's also a bus stop at the end of the block here in the distance. The transit agency is probably not happy either. So, a little coordination, communication between the public sector and private sector in this case maybe would have gone a long way. I don't know which came first, but say the sidewalk closure on the right did, and maybe the street department could have delayed this project or accelerated the project to get it done before the sidewalk was closed on the other side of the street. Just things like vehicles, equipment, materials should not block sidewalks. I like to think of the sidewalks and bike lanes too, as lanes. They're lanes of traffic for users. We wouldn't allow that landscaper's trailer in the left image there to probably block that right lane of traffic for several hours. So we shouldn't allow it to block the bike lane or the sidewalk for several hours. And again, that would be an ADA violation. This is sad too. Notice the construction fencing is outside of the pedestrian push button. So now the pedestrian push, the signals are basically inaccessible. Again, more examples of storage on the left there. In this case, there's a sidewalk only on this side of the street. And notice all kinds of stuff there. Sections of fencing, the porta-john, it looks like maybe a skid steer or a lift or something in the background. So that sidewalk is inaccessible now, and there's no alternate route for pedestrians. The right image shows a real challenge. That sign, that roadwork sign, is required by the MUTCD for vehicular traffic, but it has now made that sidewalk inaccessible. And right off the top of my head, I'm not sure I see where that sign could be relocated, but we really need to think about how can we provide that information to motorists, but at the same time not block the sidewalk. Same thing with crosswalks. They need to be kept open, or if they're going to be closed, like the image on the left here, what we really should do is put some sort of detectable barricade on this corner so that pedestrians don't even get into the street to begin with. Hopefully everybody has policies related to accessible, detectable, alternate pathways. If you do, then be sure you revise them regularly to make sure they're up to date, and enforce those policies and document why you did something, or if you couldn't quite comply with the requirements, why it is still accessible to the maximum extent feasible, or how you made it accessible to the maximum extent feasible. So I'll welcome questions. I'm going to continue to move on for a few of these examples, then we'll open it up to questions. But I have a few example installations to show you, and we can just talk about and maybe address in the questions. The first two slides actually come from Victoria Beal at Ohio LTAP. Apparently, someone from FHWA sent these images to her, and these are just things that were found during a Federal Highway Administration spot check of projects. And notice here, you can see they have a median refuge area, but the portable sign and its feet are basically blocking the path here in the pedestrian refuge area. And it also looks a little strange. It's outside the scope of this class, but these Z crossings, as they're called, are very popular. But usually the idea is that when the pedestrian crosses the street in the direction we're looking here, they would turn to the right, and the pathway would take them a little bit to the right so that as they're walking, they can check for oncoming traffic and they can see the traffic stream they're about to cross. Here, they're walking away from the traffic stream they're about to cross, so they sort of have their back to traffic. But anyway, the key issue here is accessibility of that refuge island. Here's another example from an FHWA spot check. Notice the whole corner is dug up, probably to put in compliant ramps, I hope. But notice that the use of tubular markers with yellow caution tape strung between them is not a detectable path. And also, there probably should have been something on this corner that we see to prevent pedestrians from getting into the crosswalk to begin with. On the bright side, I would say it looks like they are doing this in a staged way. I see some communities where all four corners are excavated and up, and then there's no accessible path or route through the intersection for pedestrians. Here's another one. If you recall earlier, I talked about avoid black for the bases of signs and supports and things. Notice here, the feet of these type 3 barricades project into the marked crosswalk. And what happened here, this is a sad situation. This was actually an incident that led to a tort claim, a lawsuit involving unsafe placement of the barricades. It was a rainy night. Two women were walking together, walking in the direction you saw from that previous photo. And the woman who was on the left tripped on the angle iron feet of those type 3 barricades. It was dark and she said she never saw it. And she actually suffered a serious arm injury, permanent injury. So she filed tort claims against the municipality, against the general contractor, and the traffic control device subcontractor, alleging negligent placement of the barricades that created a hazard for pedestrians. The subcontractor who placed the devices, he said that his crew placed them such that the feet were outside of the crosswalk, that they had been to safety training and they knew better than to put the feet in the crosswalk. But he thought that the contractor who used this roadway here for access to the job site, he said the contractor constantly going in and out there, that the contractor personnel must have restored them or put them back improperly. But in any event, a lawsuit was filed. The defendants argued that there was more than 3 feet of width available so that the walkway complied with ADA criteria. They also argued that if a walkway is accessible, it is also safe. But I hope you understand, as I've tried to talk about earlier, that just because something is accessible does not mean it is safe. And I think in this case, that was the plaintiff's argument, was having those feet in the crosswalk was not safe. And actually the parties reached a confidential out-of-court settlement just before trial was scheduled to start. One possible solution I mentioned would be to move the barricades back, keep them out of the crosswalk. Another solution might be to use a different type of support like the one here. Notice there's a type 3 barricade, but it appears to be fastened to the channelizer there such that you don't have feet protruding into the crosswalk. Let's look at a couple examples maybe. And I realize I forgot a poll question. Sorry about that. But Mike, in a minute, I think I'll ask you to put the second poll question up if you can do that.
Sure.
But this situation is, it's a West Virginia example. I won't identify the city, but the gas company removed a section of sidewalk and excavated a trench to repair a section of gas line. And after the pipe was installed, the gas company backfilled the trench and put a stone surface that you'll see. And under the way this gas company operated, when their crew did that, they would notify a concrete contractor who they had on retainer. And by contract, that firm has 3 weeks to replace and finish the concrete. The sidewalk is in downtown, but outside of the business district, has some pedestrians per hour, and it's located in front of a museum. So here's the situation. This is how the gas company left it. And Mike, if you would put the poll question up,
All right.
asking you, how would you make this sidewalk section accessible? And there's a number of choices there.
Okay, and the poll is open, and we see the first few responses already. We have some additional responses. That's good. We'll give a few more seconds. Okay. And here's the results. Ron, 32% said A, 35% said B, 29% said C, and 4% said D.
Okay, good work. Yeah, I'm not sure there is a right answer to this. It's going to depend on things probably more than we know. But yeah, I mean, one solution would be to say, just put a temporary cold patch over it until the concrete contractor can restore it. Or we could put a steel plate over it, hopefully with appropriate slip resistance, or maybe restore the concrete immediately. All of those are, I think, would be appropriate. So good work on that. I think, Mike, if we have some questions, this might be a good time to stop just to make sure we have time for questions. Or if we don't have questions, I can continue with another example.
We do have a question, Ron. In some of the previous slides today, we've talked about the width of the path. So we have a question from Geraldine who says, shouldn't there be an additional area of deflection that is not considered walkway width behind the temporary barriers in case of a crash?
I would say for the temporary traffic barriers, the concrete and especially the water filled, I would say yes, for sure. For the channelizers, I guess desirably, but I would say they're going to move so much or else be destroyed by the vehicle impact that it probably doesn't matter. Their main purpose is just to separate pedestrians from the vehicles. There's no intention to sort of, quote, protect them from a crash, as much as we'd like to. To do that, though, you need the crash-worthy devices. But yeah, especially if you use the water-filled device, I think it's a good idea to have additional width to allow for the movement of that. But that could be considerable. That can be up to like 10 to 12 feet.
Thanks, Ron. We have a question from John who says, we are working on a bridge replacement project with walk on both sides and can only maintain walk on one side during construction. The nearest existing marked crosswalks are 2,000 feet from the proposed closure points. Is this too far for a pedestrian detour? Concerned that a temporary mid-block crossing could be hazardous to pedestrians.
Oh, good question. And not to be a smart aleck, but the answer probably is it does depend on maybe even more than you've mentioned. But yeah, and this is just my opinion based on what you've said, but probably 2,000 feet would be a tough detour. But again, you have to look at what the situation is. If it's like that high-rise senior housing that I mentioned, and they would have to take that detour to get to the Walgreens or the CVS or something, I would say definitely that's too far. But if it's another sort of population, maybe it's not, but it just seems like 2,000 feet probably is too far. You may want to explore some other things, or if nothing else seems to work, then I would be sure to document that it is because of safety reasons that you had to have such a long detour. Or again, I don't know if it's a bridge project, it's probably going to be a lengthy project, maybe a year or two or something. I'm just imagining. And there you may want to think about something of just I don't know if it would be on demand or maybe, from 7 a.m. to 5 p.m. or something, but even have some sort of a shuttle service. So somebody who couldn't travel that 2,000 feet or maybe 2,000 feet back, you're at least providing accessibility to the maximum extent feasible. So consider those types of things as well, maybe as some of your options. But yeah, that's a very good question, and it's going to depend kind of on your site-specific context and situation.
Thanks, Ron. We have actually reached 2:30, and I want to mention that in the PDF handouts, the email address for Ron is provided. So if you have some additional questions, you could send those to Ron by email. Really, I just want to thank Ron Eck for teaching this webinar series. We greatly appreciate it. And thanks so much, everybody, for participating in this course. So Ron, any final comments?
No, I just want to echo your comments. Thank everybody for participating, and thanks for your great, insightful questions over today and on Tuesday. I appreciate it. And also mention that feel free to follow up with emails to me. I'm always glad to try to respond that way. And thanks everybody, and have a good rest of the day.
Thank you.